got triangle PQR, and there's a right angle at Q. Angle QPR is 60 degrees, but the bisector of this angle meets QR at S. Now, what that means is that this angle is 30 and this angle is 30. And a follow-up then is that this will be 60 because we have QPS and we're just missing that one angle. Then this will be 120 because we've got angles on a straight line. And then this angle will be 30. Okay, we want the ratio QS to SR. So one thing to note actually is that the right-hand triangle is necessarily isosceles. And so actually I want to, if I can find QS to PS, then that would be exactly the same. Now I'm just going to say, and I can do this, say that this length is actually 1. SR is equal to 1, which means that SP will also equal to 1. If I now draw this triangle, I've got a hypotenuse of 1, I've got a right angle, I've got, let's put 60 degrees in here, then I can work out this length. Now, a really quick way of doing it is to recognize that actually we've got half of an equilateral triangle. So this must equal a half. And then we're actually there. It's going to be a half to 1, which becomes 1 to 2. If you don't spot that, then, and I didn't actually, I've got to be honest, I am getting better at spotting it in questions. You can go and use your exact trig values. So cos 60 is going to be the adjacent divided by the hypotenuse. So actually, in this case, just the adjacent. And cos 60 is equal to a half. There's ways to prove this. There's ways to remember it. I'm not going to talk about them here. I've done it in many other videos. So it is a half, and then that will again give us our answer. In the answers, they do one other method, and that is to use the exterior angle, sorry, not the exterior angle theorem, the angle bisector theorem. And I'm just going to talk about this briefly. I think it's overcomplicating this question. It doesn't actually feel like it's a better method. It's just a more general method. But what it says actually is that QS divided by SR, because that is how here's your bisecting angle, and the line that comes down then splits QR into two. Actually, that is then equal to QP or PQ divided by PR. I'm not going to go into any more detail on how to use that to solve it, because again, it just doesn't seem as simple as this first method, but it is something to look into. You might be interested in the proof. It's called the angle bisector theorem. Yeah, and one thing I would just say at this point, I don't often say it, is, as well as trying to get these questions correct, it is always good to look at the solutions and look at alternatives because it just builds your knowledge that little bit by bit. You always have gaps in your knowledge. I'm done many of these challenges, but I'm still learning things. So my advice would be to, obviously watch my videos, but also have a look at the official solutions as well, because sometimes I don't go into everything they're doing. And even if I do just mention things like the angle bisector theorem, I then leave it to you to investigate it.